Hello students, welcome to mathematics class. Students, this is part 3 of the chapter Introduction to Graphs. In this part 3, we will continue solving the questions from exercise 15.1 and later we will go for learning new concept called linear graphs. This video you are going to watch on 2nd February 2021. Coming to the continuation of exercise 15.1, we solved in our previous class up to the question number 4 of the exercise 15.1. So now we will continue solving from the question number 5. Question number 5 contains sub-questions. This is about drawing linear graphs. Here we are provided the number of days a hillside city received snowfall in different years. In 2003, 8 days it has received. In 2004 for 10 days. In 2005 for 5 days. And in the year 2006 it has received for 12 days. Now we are asked to draw the linear graph for it. Now we will go for taking a graph sheet, plotting a vertical axis, which is we will be considering days on it, and horizontal axis where we will consider years on it. Now what I will be taking here, first I am considering a kink so that I will take from here 2003, 2004, 2005 and in the 2006. This 1 unit I am considering years. Then I know that here minimum value is 5. So here also I will consider king. I will start with the 5, 6, 7, 8, 9, 10, 11 and 12. Now for me, the moment I considered scales, that is here scale for me 1 unit is equals to 1 day on vertical axis. On horizontal axis 1 unit is equals to 1 year. Now I will show 8 corresponding to the year 2003, 2004 corresponding to that I will show 10, then 8, 10. In the year 2005 it has received only 5. Then in the year 2006 whereas snowfall is for 12 days. So now if I join with the free hand, so this is, you can draw with a scale also, using scale, rather freehand curve you can draw scale, using scale here. While drawing curves, freehand curves, we will get like this. Instead of that we can go for drawing a straights. So this is the method of plotting a graph. Then coming to the sub question 5. Sub question 5 is about population in thousands of men and women in a village in different years, where number of men in thousands, number of women in thousands, and we are asked to draw graph for it. So here we need to draw double line graph. So let's go for it. Here I have taken similarly again vertical axis, wherein which I will be showing number of men or women in thousands. It is, it will be in thousands, whereas I have taken horizontal axis on which I will be considering years. So first I will go for putting a kink so that it becomes from 2003, 2004, 2005, 2006 and 2007. Then further here also I am putting a kink on vertical axis. I will start, your minimum value is 11, so I will start from the 11, 11.5, 12, 12.5, 13, 13.5, 14. So here in one unit I have got 5 subdivisions. So I can make now this as 11.1, 11.2, 11.3, 11.4 and 11.5. So I have chosen on vertical axis scale 5 subdivisions as equals to 0.5, or I will take 10 subdivisions as 1000. So 10 units on y axis, on y axis, this is y axis, so is 1000. I have written in the form of k. Now in the year 2003, number of men, see, better I choose men with a dotted line and continuous line as number of women. So on y axis I have chosen a scale, you know that. On x axis, one, you can say 5 subunits as units only. 5 unit equals to 1 year. So I will first take men's. In the year 2003, 12 were there, point I have considered. In the year 2004, 12.5 were there. In the year 2005, 13 were there, and in the year 2006, 13.2 were there. So 13.2 becomes this one, and in the year 2007, 13.5 were there. So this is number of men's. So number of men in 1000, it is in 1000. Now I will go for now constructing number of men by changing a color. I am changing a color. I will consider now a different color. Maybe better I go for considering maroon. 11.3 in the year 2000. So 11.3 is this one. So in the year 2004, 11.9. So 11.9 is this. In the year 2005, 13. In the year 2006, 13.6. Then it becomes this one. In the year 2007, 13.5. Sorry, it is 11.3, 11.9, 13, 13.6 and 12.8. So 12.8 is 13 and below that here 2. So better I'll draw straight 1, 2, 3 and 4. So this is number of women. So I have drawn both the line graphs. So now we can easily compare. Okay, students. Now coming to the question number 6. A courier person cycles from a town to a neighboring suburban area to deliver a parcel to a merchant. His distance from the town at different times is shown by the following graph. That is from 8 am to 12 noon. Time is considered on a horizontal axis. Distance, that is cycles in kilometers, is drawn on vertical axis. So he starts at 8 am and reaches somewhere at here. Now we need to know scales. First, scale on x-axis, that is, this is x-axis and this is y-axis. So first we'll go for identifying scales. Here on x-axis 4 units equals to 1 hour. That means 1 unit is 15 minutes. On y-axis 1 unit equals to 2 kilometer. Now it is easy for us to identify anything on this graph and it is easy to read now. They have asked questions. What is the scale taken on the time axis? We have already shown. Okay, 4 units equals to 1 hour. Okay, then another question. How much time did the person take for the travel? How much time has he taken? He has taken 8 to 11:30. It is 11:30. That means he has pedaled up almost for 3.5 hours. Okay, he has taken 3.5 hours. Now moving further, how far is the place of the merchant from the town? It is almost, he has traveled 22 kilometers. 22 kilometers. Next, did the person stop on his way? Explain. Yes. Why I can say? It is because of this. He stopped. It is because of a line parallel to it is because of as there is a horizontal portion as there is a horizontal part in the given graph, which indicates that he has stopped from 10 a.m. to 10:30 a.m. So he was stable. So this is how we answer. Now last question, during which period did he ride fastest? There is another question. Okay, so I have written this explanation, over that it comes. During which period he rode fastest? So here is the question. You could see a sharp height here, sharp part of this, vertically it is moving 8 to 9. He has pedaled for 10 hours. So for this I will write solution here. From 8 a.m. to 9 a.m. he was fast. Okay, then this is the 6th question. Now we will go for 7th question. Here the question is, can there be a time temperature graph? Can there be a time temperature graph as follows? Justify your answer. Now first one, as time proceeds, temperature increases. It represents time temperature graph where temperature increases as the time increases. So it is possible. Yes, it is possible. Next, second one, as the time proceeds, temperature is decreasing. This is also possible. Dropping of temperature as the time proceeds. It is possible. Now, next, another part. Third one, as time is same, stable, temperature is keep increasing. So it is not at all possible. So this is not possible. Third one is not possible. So fourth one, where as time increases but temperature never changes. This is also possible. Sometimes though the time is changing, temperature remains same. So this is possible. So these are the questions from the exercise 15.1. So we have completed all the questions from exercise 15.1. Now we need to know something about linear graphs. Moving to the linear graph, a line graph consists of bits of line segments joined consecutively. We did just now, joining points, bits of points with the continuous lines. Then sometimes the graph may be a whole unbroken line. Such graph is called linear graph. Okay, unbroken. I have shown number of women with unbroken line. These are linear graphs. Then to draw such line, we need to locate some points. Very important, we need to locate some points on the graph sheet. So now we have to learn how to locate a point on graph sheets. We will learn how to locate points conveniently on graph sheets. Okay. See children, we will do this learning in our next class. Why? Because it's almost 19 minutes. I don't want to make a starting of this concept and becomes huge. Okay. And overshooting the time. So I'll be talking very important about one of the famous mathematician, French mathematician, that too, René Descartes, who is called father of this graphing techniques. So in our next class we will learn all these things. So till then, take care of yourself. Thank you. Jai Hind.